Okay, we are discussing about the transient response in electrical circuits. So, in the previous lecture, I discussed about the initial conditions as well as steady state conditions with respect to inductor and capacitor. So, just to have a quick summary here, in case of inductor, if the initial time is at t equals to 0 seconds, and if the current flowing through inductor is 0 amperes at 0 minus seconds, it will be same even at IL of 0 plus, that is at 0 plus seconds. Why? Because inductor doesn't allow sudden changes in the current. So at initial time t equals to 0 seconds also, that means inductor behaves as open circuit. So this is the case when there is 0 ampere current before the switching action, that is at 0 minus time. Suppose if that current is not 0 amperes, if it is 2 amperes, then at time t is equal to 0 seconds, the current will be 2 amperes. Okay, so whatever is at 0 minus, the same current will be there at 0 plus. It means at time t is equal to 0 seconds, that is also equal to that particular value. Similarly, in case of steady state condition at t tends to infinity, the inductor behaves as short circuit, and in case if the current is 2 amperes, at the steady state the equivalent circuit will be like this. It is a short circuit, and of course because of the initial current 2 amperes, it will be considered in this manner, right? Okay, and make a note that this short circuit is only for the step input, for the DC input only. That also I have clarified. And coming to the capacitor, if it is 0 volts before switching action, again it will be 0 volts after the switching action, that means just after the switching action. So the capacitor voltage will be short circuited. And if there is some voltage 2 volts, we are going to consider that 2 volts at initial time like this, right? Okay, this is the initial conditions and steady state conditions for step input. Okay, let me clearly write here. This is t tends to infinity condition only for step input. Okay, right, perfect. Okay, now mainly in this lecture we are going to discuss about transient response of series RL circuit, and we can solve this very easily because of the homogeneous differential equation comparison. So as per this circuit given conditions, the switch will be closed at time t is equal to 0 seconds, and there is a step response. This is a DC voltage of value V, and series RL circuit it is. Okay, so at time t greater than or equals to 0, the switch will be closed. So we are replacing the switch with short circuit, and there becomes one loop here, and we need to write the loop equation. Fine. So when you write loop equation, it is a KVL application minus V. I am starting at this point, right, and minus V plus RI of t plus VL of t is equal to 0. And when you express this as a proper differential equation by dividing with capital L, you will be getting this. Okay, and so we have expressed this as a proper homogeneous equation so that we can compare it with dy by dt plus py is equal to q. So this kind of equations are having direct solution, which is equal to y of t is equal to e power minus pt integral q e power pt dt plus k e power minus pt, where p is this coefficient of y and q is the right hand side term. Okay, so in the same manner, if you compare this with our differential equation in terms of current, y will be equal to I of t. So what will be I of t? I of t will be equal to e power minus r by lt, because here the coefficient of I of t is r by l. What is q? Q is equal to constant v by l. Okay, this is fine. Then how to determine k? So k you will be determining using initial conditions. What is the initial time here in our circuit given? It is t is equal to 0 seconds. That is called initial time, and we need to have an initial condition to get capital K, right? Okay, now when you integrate and simplify all the things, you will get I of t is equal to v by r plus k into e power minus rt by l, and here k has to be determined using initial condition I of 0. Okay, so now we are considering 0 initial conditions. Okay, that means IL of 0 minus is equal to 0 amperes. Okay, this is our assumption, let us say. Okay, so this IL of 0 is our assumption. Okay, so when IL of 0 minus is 0 amperes, IL of 0 plus will also be equal to 0 amperes. That means overall I of 0 is 0 amperes. Now at time t is equal to 0, you just need to substitute this current is equal to 0 in this equation number 1. Then you can get capital K. That means whatever is the constant. So that constant is equal to minus V by R. Then when you substitute that constant back in our equation, what do you get? You will get the exact current response in series RL circuit. Okay, so then finally you are getting this kind of response, and for this response if you plot a graph, you will be getting like this. On x-axis it is time response, right? It is response of current with respect to time. That's why it is called time response. So x-axis is time, y-axis is I of t, and you are plotting, you will be getting like this. So after certain time it will be reaching steady state value, which is equal to V by R, right? What is steady state value here? Steady state value will be obtained when t tends to infinity. So when t tends to infinity, I of infinity will be equal to V by R. So that's why this is considered as steady state. Okay, so there exists some time difference from initial time to the steady state, that is called as time to reach the steady state value. So that value is nothing but 5 times tau here. So what is this tau? This tau is considered as time constant. Okay, so this tau is nothing but the time taken for the current response of an inductor to reach 63.2% of the final value. So final value is nothing but steady state value here. Okay, final value is nothing but steady state value. So when you derive the time constant with respect to this definition for a series RL circuit, you will be getting it as L by R. So it is a very easy derivation. So at time t equals to tau, the current should be equal to 63.8% of steady state value, and we already know that steady state value is V by R. So when you use this condition by substituting t is equal to tau, you will get the value of tau, which is equal to L by R. Okay, this is not proportionality constant, it is equals to. Okay, this is all about the inductor current response in case of series RL circuit for step input. So in the next class we will see it further. Okay, that's it. Thank you.